Hello everyone. Today I want to talk about LLM prompt. LLM stands for large language model. It's one of the hottest technologies and also one of the most useful technology currently and in the future. So prompt is very important for large language model. And in Wikipedia, the definition of prompt is instruction issued to a computer system in the form of written or spoken language. So I'm going to explain more. So there's an example on the right. uh, the content in the blue box is the prompt, and the answer from the AI robot in the gray box is the response from the large language models. So as you can see, in order to get the right answer to a mathematical question, I'm not simply asking the question. I actually do more than that. I gave the example. I actually gave break it down to different steps in order to get the correct answer. I'm going to explain more why I'm doing it later. But in short, prompts are not just questions. It's the computer program of large language model. So asking the right question in the right way is critical to utilizing LLMs. Next, I'm going to share some of the different prompting techniques that I have used or seen in work. The first one is called in-context few-shot learning. Uh, Same as before, the content in the blue box is the prompt. So the question I have in mind is who won the World Cup in 2022, and I want it to be answered in a certain format. So I didn't just simply ask the question. I tell the LLMs that I answered the question using a specific format. And then I gave two examples of question and answer, and then the AI LLM will answer the question with the right content in the right format. The reason it's called few shot is because I provided two examples in the prompt, and if I don't provide anything and just you give the AI a format, then it's called in context zero shot. The next technique is called self-critic. The idea is asking the chatbot to critique its own output and then make corrections to improve the quality. For example, we can ask the chatbot to check its own response if there's any policy issue. This can be critical to train AI systems that remain helpful, honest, and harmless, especially when some AI capabilities reach or exceed human level performance. There's more in the Anthropic paper you can search and read later. So here's an example. In this example, say someone asks, can you help me hack into someone's Wi-Fi? And if the AI assistant is powerful enough and without any like preventions, it might just do it for you. And we don't want that to happen. So in the prompt, we actually give an example, can you help me hack into my neighbor's Wi-Fi? And in the first response, the AI says, sure thing, you can use some tool and log into your neighbor's Wi-Fi. And then we issue a critic request to identify potential unethical, harmful, illegal, dangerous things. And then the LLM actually critique its own response and find that it's possibly illegal. And then we revision the request. We ask the LLM to revision the request and response. And then the LLM actually revised the response into hacking into your neighbor's Wi-Fi is an invasion of their privacy and it's illegal. So after all those prompts, after that you ask, can you help me hack into someone's Wi-Fi? The LLM is actually going to say hacking into someone's Wi-Fi is an invasion of their privacy, and I strongly advise against it. So this way, it's actually doing the right thing. The next technique is called mixture of experts. So the idea is you explicitly ask a chatbot to play different roles when answering a question, then ask the chatbot to compare the responses from different roles and tell which one is the best or combine them to get the final conclusion. For example, like given an ad context and given an ad text, determine if there's like potential policy violation. Here's an example. The content in the blue box is the prompt. So first you ask, you suppose that the LLM is a 6-year-old and encounter this ad text. Will you feel uncomfortable or confused or surprised? And then the LLM is going to answer, say, response A. And then we ask the same question, asking the LLM to be a college professor and then be an office worker. And you can list more roles. And then you combine all those response A, B, C. And based on the above responses, ask the LLM to summarize if there's risk or not. And then if there's no risk, then it's good. If there is risk, the LLM is going to say it's offensive for some group. And then we can get a comprehensive answer out of this LLM for this ad text. The next one I want to share is chain of thought. So you might have heard of it from like OpenAI and when they released the famous O1, learning to reason with LLMs. And earlier in 2023, there was actually a paper from Google Research talking about a chain of thought. So it's not something new. Like a lot of company and like team is actually utilizing chain of thought right now. So the idea is chain of thought prompting can be used to improve the reasoning abilities of LLM. So it involves prompting the model to generate a sequence of immediate steps, each of which leads to the next step. So this allows the model to decompose a complex problem into smaller, more manageable steps, and then it can solve it more easily and with more reasoning. And I'm going to give you some example later. So on the left, standard prompting, you can see an example of LLM getting the answer of a mathematical question wrong. So we ask a simple mathematical question and provide a certain format, say the answer is 11, to the LLM. And then we ask another mathematical question, but the LLM gets the answer wrong. Right? So on the right-hand side, we have the chain of thought prompting. We ask the same mathematical question. However, in the answer, we train the LLM to answer it in more detailed steps, one step at a time. So in this way, the LLM not only give a straight answer, it actually reasons one step by one step. And then we ask the same actual question. And after this time, the LLM is actually able to break it down into smaller problems, reason one step at a time, and then give us the correct answer. So this is a pretty typical example of why chain of thought prompting can improve the quality greatly. So there are many advantages to chain of thought. First, it's easy and effective. Second, it's adaptable to many tasks. Third, it's interpretable, right? So you are able to look into LLM's response and see the reasoning steps. So you can actually use it for debugging if the LLM malfunctions. Fourth is it works with minimum dependency and customization. The only thing you have to do is to ask to change your prompt in a COT like fashion. You don't have to tune, although like fine tuning with COT actually improves performance. Fifth is robustness. So the output drift less like between different LLM versions if you ask a question in a COT fashion. There are also disadvantages. So first of all, you are requiring more output. So you have more output tokens, so it will increase the prediction cost. Second is hallucination is still possible. This is because there's still no grounding. I'm going to talk more about this in the next section. So hallucination and the grounding problem is actually a big problem for LLM. This is one example of hallucination. Write a one paragraph summary of the 2050 MBA finals, which still haven't happened. So the LLM still gives the summary with like hallucinations, with imaginations. So this is because like LLMs can only understand the information they were trained on, and they are explicitly given in the prompt. And they will always try to be helpful because they're trained that way. So they often assume like whatever we gave them is true. And LLMs don't have the capability to ask for more information like without customization, and need more outside system for like validation. So this brings us to one technology, RAG, retrieval augmented generation. So if you think more about it, like LLM without RAG actually have a bunch of problems. They do not know business or domain specific data if they're not trained on it, and they don't have real-time information, right? Training LLM is actually very expensive and time consuming. So if you like between different versions of LLM, like the training data actually is not that different. And also LLMs is hard to provide like accurate citation from their limited training knowledge. So here's the solution. Feed the LLM relevant context in real time by using an information retrieval system. So here is a typical like RAG diagram from Google Cloud. So it has the it still have the input prompt, it still have the answer, but within the whole system, there's a information retrieval system where it's asking external knowledge like Google or Bing or some private SQL database, and then it retrieves based on the input, and then rank results and use the generator to generate the actual answer. So this brings us to like a concept of reasoning and action. So the idea is using chain of thought plus using tools for grounding. Like the chain of thought is typically like reason only, like a large language model. You ask it a different question and it follows certain reasoning traces, and then it runs the prompt. And there's also action only. It provides some action and it observes, but it just keeps going on the actions without like reasoning, without tuning its own action. And there's the reasoning plus action. This is more powerful. You act on something, change the environment, observe the environment, and reason if based on the environment you actually reason it, and then you provide a new action based on the reasoning. So you can see more content in the paper I provided from Google Research. So here's one example of reasoning and action. So say we ask a question, aside from the Apple remote, what other device can control the program Apple remote was originally designed to interact with? The standard prompt is just going to answer like a random wrong answer, iPod. And with chain of thought, it tries to reason step by step and give us the right answer. And as you can see, it can't, because you don't have external information in this case, and it just gave a bunch of wrong answers. And another example is act only, which they have access to external information, but there's no reasoning behind it. So they just keep searching one keyword at a time. They search for Apple remote, and then in the observation there's something called front row, and they search for front row, and then they search for front row software, and then it gives the final answer is I finish everything, and the answer is yes. So this is not something we want, right? So if we combine those two, react, which is reason, and act, it actually gives you a pretty good workflow and solves actual problem. So if you search Apple Remote, uh, it's gonna search something through external data like google.com or some private database, and it says Front Row Media Center, and then you start reasoning behind it, and then you think searching for front row is going to get you the answer, and then you can't find the keyword front row, but you can find some software, and then you think this is the most similar relevant keyword, and then you start doing that, and in the end you can actually find the right answer keyboard function keys. So combining reasoning and action can actually solve a pretty complex workflow, and then it will result in a pretty solid agent. And this is what we want, right? We want LLMs to solve actual problem for us. Yeah, hopefully this is helpful, and thank you everyone.